Well, today we're going to be examining how audio microphones work with environments that we find ourselves, that is video conferencing environments, using tools like Zoom, and the dynamics that are involved for those of us that focus on how to be communicators. Today we're going to be examining a little bit of theory about audio, the mechanics of sound, and how they impact on these devices that we're constantly working with called microphones. So let's start. First, we should really spend a moment really having a basic understanding of what is sound. What is sound all about? How does it work? And fundamentally, we as human beings hear the spoken word through a process that involves changes in density of air pressure. Now, that's not initially obvious, but that's really what's going on. We use the mechanics of our bodies to project air, and we change the frequency and the cadence, and we do all kinds of things with our voices that change the way those densities and air pressure go out, and the carrier is air. And those changes in density and air pressure are understood by the recipient of the sound. Humans hear by processing changes in air density through the use of their eardrums, and they can interpret that in many different ways. So we first need to really appreciate that's what's going on. So what is a sound wave? We use this as a term, and really it's just a term that really helps us give expression to the concept of what we call vibrations, changes in density and air pressure. So but the word vibration just says it in a more succinct way. The medium we're working with is air, and when we send out sound waves, which is what we're doing when we're speaking, those sound waves can be impacted by different surfaces. So for example, sound waves can bounce off of drywall. Whereas if you have an audience absorbs sound, doesn't reflect it back, doesn't deflect it, absorbs sound. That's why you will find as a communicator, when you're just using the spoken word, you have to project with a larger voice the greater the size of your audience, because there are actually more people absorbing the sound. So we recognize vibrations moving through the air, and we use an identifier word called frequency. And if you look at this chart, you can see that we map out vibrations in the air, sound waves, by using a chart called frequency. And if you look at this, you'll be saying to yourself, wait a minute, this looks awfully like when I'm watching any kind of drama series involving the medical profession, and someone's having a heart attack, and they got them on a heart monitor, and bip, 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 bip. And here's what's funny about that, I find this funny, is that the device they're using does not measure a heartbeat. You are seeing a device that's measuring the sound of a heartbeat. And the little flashy symbol that you see, that we all have come to recognize as the symbol representing a heartbeat, is really just a measurement of sound. So it makes it so interesting to me, anyways. So the higher the frequency of the sound waves, the higher the pitch. That's just another way we measure sound. The lower the frequency, the lower the pitch. Audio equipment identifies high frequencies with the word treble. Now, for those of us that used to have analog stereo systems, and you still see these settings in your car when you're adjusting sound levels, and you'll see the word treble and you'll see the word bass. And treble just means the higher frequencies. Bass means the lower frequencies. And here's a tip. As communicators, we are operating with the spoken word in the treble range. That's where we are, in the treble range. Not treble, treble. Lower frequencies, what we identify as bass, we can actually feel the vibrations. So you're in a room, someone has a stereo system, got a woofer on it, you can literally see water shaking in glasses because of the power of the bass frequency sound waves. So we use a word called loudness. It describes the amount of percussion that's in the sound. The greater the intensity of the sound, the louder we perceive it. And we measure this using a word called decibels. So decibels is a measure of the loudness of sound. And what's interesting about this whole topic is that inexpensively, anyone can download to their smartphone an application that will convert their smartphone into a decibel reader, where you can measure decibel settings, how loud someone is being in the room. I enjoy doing this when I'm doing evaluations of any kind of speech presentation, because it tells me the experience and the power developed by the speaker and their ability to take command of that power. Here's a nice little chart that really sets it out in a very nice way, in which we can see that a whisper is about 15 decibels. When we find ourselves in a noisy restaurant, that's usually at 80 decibels. The average home, average conversational style is at 50 decibels. And once we get into the higher ranges, we can actually inflict pain on the recipient of the sound. So these really tell us a lot. Whenever I'm working, for example, I have a hobby as a DJ, and whenever I'm setting the sound levels within the room and balancing the speakers, I will go around with my smartphone as a decibel reader, and I will be, really measuring what the upper end of my volume settings are. Usually I set them to 90, and then I will bring them back down with the levels in my audio mixer to the point where they're sitting at 50. And whenever I'm having a situation where there's an evening meal followed by a dance, I will normally start with the sound levels, background music for the meal, at about 40 decibels, and I'll quietly step up the decibel level as the evening progresses. So this can be a very useful measurement tool when you are working in the spectrum of audio, sound, especially as it pertains to your Zoom meetings. So shouting is 80 decibels. Normal conversation, 50 to 55 decibels. Pain is experienced at 120 decibels. Now, what's interesting about microphones, which is the topic we have at hand today in this first episode of several series, is that let's focus on how a speaker works. And you may have asked yourself, holy smokes, why is it a speaker can recreate sound with such clarity, it's almost as if I'm at the original event? How is that possible? And the answer is that the mechanics of a speaker is identical to the way in which the original sound was generated, and that's why it can be mirrored so well. And really how it works is that you will find that there is a device, an electrical device, that creates vibrations. The vibrations are transferred to the diaphragm, which projects changes in air density because it's vibrating. And so it's using exactly the same mechanics that the musician or the speaker is using when it projects changes in density and air pressure, which is why it can mimic the original sound with such clarity. Now, what's interesting about a speaker device, and some of us have actually taken the time in our lives to open one up and disassemble them and take them apart, and you'll see it's very, very similar to this layout that we have here. What's interesting about microphones is that they're exactly the same device, only the polarity is reversed. So instead of sound going out, the diaphragm collects the sound going in to the magnet that is set to understand the vibrations and to turn them into electrical signals. So a microphone is just the reverse of a speaker. You can convert a speaker into a microphone. Simple physics and mechanics. So just a very interesting point. I found it very interesting when I first learned this. So when we deal with speakers, they're an important part of any audio solution. We have to think about positioning them. Elevating speaker height can really improve their performance in terms of getting the information out to your audience. You know, you can deal with all kinds of different speakers. They've been really dropping in price dramatically in the past few years, and they're very, very affordable now. So when we're dealing with microphones and speakers, we want to think about some things as we work with these tools. There's some pitfalls with microphones, especially when they're too close. You'll hear a popping sound most specifically when you're using the words "p," that "p" sound, you know, Peter, Paul, Pepper. And it's because that particular sound actually expresses a significant higher amount of air expression than we normally do. And so whenever you encounter as a speaker a "p" sound with a microphone, all you need to do is just move it further away. That's all you need to do to allow more airspace between you and the speaker. Some individuals will cope with that by putting a barrier. You know, sometimes a sock is put onto a microphone, what they call a sock. It looks like a little fuzzy ball. And sometimes you'll put a screen between them. We will cover that in episodes to come as we start examining these devices in greater detail, both in their USB format as well as their XLR format, which would be something you would traditionally see with an audio mixer. Remember, when you go into a hotel setting, that invariably the sound levels were set when the room was empty. They need to be reset when the room is full because people absorb sound. And one barrier that we all have as communicators is that we need to spend time getting comfortable hearing our own voice, and with Zoom, getting comfortable with their own appearance. A lot of people aren't. It takes some work, it takes some practice. Yes, you have to pay attention to your appearance, the clothes you make, the background that you're working with. All these are true. So I'm just going to end this particular episode with just a basic introduction to the fact that microphones come in all kinds of shapes and styles. When someone hands you a microphone, you should be wary because different microphones act in different ways. And so we should always be aware of that. There are many different types, and in our next episode, we're going to start exploring the various different types of microphones, how they work, and how they go about doing their job. See you soon, and best luck with audio.